Okay, imagine this for a second. What if you could take a messy, chaotic folder full of raw data, hand it over to an AI, and get back a fully finished professional research report? It's kind of been the holy grail of data science for years, and today we're going to look at a new AI that might actually pull it off.
All right, here's our roadmap. First, we'll dig into why this is such a massive challenge to begin with. Then, we'll see why the AIs we have right now just aren't cutting it. After that, we'll get into the main event, a totally new approach with an AI called DeepAnalyze. We'll see how they train it, how it stacks up against the giants, and what this all means for the future of, well, everything.
So, first things first, why is it so ridiculously hard to get a machine to truly think like a data scientist? Let's unpack the real problem here.
See, the ultimate goal isn't just about answering a simple question, right? It's about automating the entire pipeline, the whole shebang. You start with a jumble of raw files, could be anything, spreadsheets, databases, you name it, and you want the AI to go off, do its own open-ended research, and come back with a complete, insightful report, just like a human expert would.
And that journey is, to put it mildly, complicated. It's a whole series of steps that all depend on each other. Any AI trying to do this has to master all of it. It's got to prepare the messy data, analyze it for patterns, maybe build some predictive models, create charts that actually make sense, and then tie it all together in a report that a human can read. It's a huge, huge task.
Now you might be thinking, hold on, we've got these incredibly powerful AIs like GPT-4. Surely this should be a piece of cake for them. Well, not exactly. They still really struggle with this whole end-to-end process. Let's look at why.
Right now, there are kind of two main ways people are trying to solve this. On one hand, you have these specialized AIs that are amazing at one specific thing, like writing code, but they can't see the big picture or manage a whole project. On the other hand, you have these workflow agents. They're like robots on an assembly line, just following a rigid, pre-programmed set of instructions. They can't improvise or adapt when the data throws them a curveball.
So the core problem with both of these methods is that they're missing two things that make human experts so good: the ability to plan their own actions and the ability to learn and adapt based on what they find. They just haven't been trained by actually doing data science, They haven't been in the trenches, working in a messy, interactive, real-world environment.
And this is where our story takes a turn. A new solution, called DeepAnalyze, introduces something called an Agentic approach. And believe me, it completely changes the game.
So DeepAnalyze isn't just another massive language model trained on a bunch of text from the internet. It's designed from the ground up to be an agent. And what that means is it can actually perceive its environment, in this case, that folder of data, and then take its own actions to achieve a goal. It's the first of its kind, built specifically for this whole data science puzzle.
And you can actually see how it thinks right here. It works in this constant loop, a lot like a human would. It starts by analyzing the problem to come up with a plan. Then it actually writes and runs code to poke at the data. It gets feedback from that, which helps it understand the data better. And it uses that new knowledge to decide its next move. It just keeps iterating, again and again, until it's ready to give the final answer.
Now, to build an AI that thinks like this, you can't just use the old training methods. You have to teach it, like you teach a person. You start with the basics, and you slowly build up to the really complex stuff.
This is the secret sauce. It's called curriculum-based agentic training. That's a mouthful, I know, but the idea is simple. The AI is put through a structured curriculum, a learning program that basically mimics how a human would learn data science in school or on the job, starting with simple skills and working its way up to full-blown research projects.
You can see that whole learning journey right here. It starts as a beginner, just mastering one skill at a time, like cleaning a data set or making a simple chart. Then it graduates to a practitioner, where it starts combining those skills to do real analysis. And finally, it becomes a scientist, ready to take on complex, open-ended research all by itself.
Okay, so the theory is fantastic, but here's the million-dollar question. Does it actually work in the real world? Let's look at the results, because this is where things get really interesting.
This chart right here tells an amazing underdog story. So on a really tough industry benchmark, this DeepAnalyze model, which has 8 billion parameters, a lot, but way smaller than the giants, it actually beats the massive GPT-4 Turbo. Now, it doesn't quite top the brand new GPT-4o, but look how close it is. This proves that this new training method is incredibly powerful. Size isn't everything.
And the researchers who built this, they knew they were onto something big. They called it a paradigm shift. A move away from those rigid, rule-following robots to truly agentic models that can think, adapt, and reason for themselves. This isn't just an improvement, it's a whole new way of doing things.
So let's zoom out. What does this all really mean for the future? What happens when literally anyone can get deep, expert-level insights just by asking their data a question?
Well, the impact could be just massive. Imagine a business figuring out why a product is failing, not in a month, but overnight. Or think about scientists accelerating a cure for a disease because an AI can spot hidden patterns in trial data that no human would ever see. It opens the door to truly open-ended research, where you might not even know the right questions to ask at the beginning. It's the foundation for a whole new generation of intelligent systems.
And that really just leaves us with one final incredible thought. For your work, for your research, for whatever you're passionate about, what problems would you finally be able to solve if you could just ask your data for the answers?